Okay, our last model we're going to look at comes from deBroglie's theories, and if you remember deBroglie, his key idea was if we can think that things that are waves are actually particles moving in a wave pattern, then deBroglie then said, well, does it work the other way around? If things that we think are particles, are they actually moving in waves? So we already figured out that it was true that things like an electron going around in an orbit should be going in a wave. Things that are a baseball being thrown is actually traveling in a wave. Just the wavelength is so small we don't see the wave pattern. And remember, we still had some problems. With Bohr's model, he never addressed the issue of Rutherford, saying that why do the electrons lose their energy if they're, or they don't lose their energy if they're giving off EMR. And some of the other issues were that his formulas only worked for hydrogen, and they see that the emission lines, some are brighter than others, so that wasn't really explained. So at the time, Niels Bohr didn't realize how much the whole quantum mechanics and his theories could have been linked together. So he showed that the electrons were in orbit, but using deBroglie's idea, basically those electrons are traveling in a wave pattern. So the key idea then is to merge those two ideas together to say, well, maybe the electrons are actually not really particles, we're actually thinking of them as waves. So the quantum model is thinking that the electrons are actually traveling around in orbit of waves, and according to deBroglie, the electrons have to be in a certain location based on a distance to actually fit a complete wave in. So we know one complete wavelength goes from start to finish, something like that. So if we were to put that around in a circle, instead of just being in a straight line, our wave would go up, and then we'd kind of reflect it back downwards like that. So one complete wavelength would make sort of a circular pattern around the nucleus. So if we had two wavelengths, that would basically, you would get sort of a four-sided shape. But we know that waves, when they hit an object and they come back, they sort of reflect upside down, so we actually get sort of a standing wave. So quite often how we draw these things is we show the wave in one direction, and then we kind of draw it going in the other direction. So for one wavelength, it would look sort of like that. If we had four wavelengths, or two wavelengths, sorry, it would be like four bumps, but it would actually sort of be like another flower sort of shape, but it'd be in between. And we know the electron then is going to travel back and forth in these two patterns. So what happens is it has to be a complete wavelength. If it's not, it's going to not make the right length like this diagram shows, so then that's not going to exist. So the idea of Bohr saying that electrons have to be at certain energy levels is true, because those energies have to match one complete wavelength. They have to perfectly wrap around just the same. And if we think of these as waves, then that's fine, because remember, particles give off EMR, if it's an EMR thing like gamma radiation or whatever, but waves don't have to. When we looked at waves in Physics 20, a wave could be a water wave or a spring or whatever. Waves didn't give off EMR. So if we think of the electron as being a wave, then this whole EMR issue doesn't apply. And this model now works for any material. It doesn't have to be just hydrogen. We can go helium, gold, carbon, whatever. This model would be the same. It's just you're going to get more orbits and more wavelengths depending on how many electrons there are. So that's sort of the key idea, that we now think the electrons are more of a wave, and because these waves are going to be going back and forth, around and around, the electron is really not at any one position. It's actually everywhere, because it's going super fast, and it's going up and down in a wave pattern, so we actually think of it as sort of being almost like a scribble. So if our nucleus is like that, our electron orbit would actually be a wave kind of going around and around. If we keep doing this, you can see it just sort of makes kind of a scribbled mess, or sort of almost like a cloud. So that's why we call it kind of like the cloud model. There is really no exact location for that electron, but it's going to be somewhere in that range. And to actually figure it out, we have to use probabilities and things like that, but for your sake, we just have to realize that the electron is traveling as a wave, making sort of this cloud type model. And this model has now been used for probably about the last 100 years, and it's still the current one that we believe is to be true. And that's it. So we're back to waves and particles sort of working together at the same time. And that's it for this chapter.